Stanford University.
On People, Computers, and Design. I'm Terry Winograd. Thank you for your patience. We had a little bit of technical work to get done before we got started, but we're in gear. Quick announcement. Next week, we have Leighton Reed, who is the co-author with Byron Reed here in the Communications Department of a new book called Total Engagement: Using Games and Virtual Worlds to Change the Way People Work and Businesses Compete. So, as some of you may know, that Byron and the students in the research group in Communications Department has now for several years been doing research on taking seriously role-playing games that people do. You go into World of Warcraft and then see how people behave, and it's a great laboratory. So this is an outgrowth of that work. So next week, Leighton Reed. This week we have two people from the research labs at Google, although I understand that Maryam will be doing most of the talking. Mike Cohen has been there. He's what counts as an old-timer at Google, although I remember him from when he was at SRI before that. Been doing speech processing for a long time, in sort of the early days of really pioneering speech processing at SRI. Maryam's younger, as you can tell, but has been there for several years, first as an intern. I actually shared an office with her when she was an intern, and then as one of the major researchers in the speech group. And there, as you know, I don't have to tell you what Google's doing, right? They've done a lot with speech as they've moved to mobile platforms, and they'll be talking about comparisons between speech and text interaction.
Thanks. Hello, can you hear me? Okay.
That's mostly for the recording.
Okay, I see. So as Terry said, Maryam is going to do most of the talking because she did all of the work. But at Google, in the speech group, we do work that spans from sort of core technology research and development to building and deploying services. And you may be familiar with some of the services. We've deployed voice search, which means on a lot of smartphones, when you're at the Google search box, you have the choice of either typing or talking. We recently deployed using speech recognition on some YouTube videos to provide captions, and that's actually hooked up to translation. So now, if you live in a country where there aren't that many YouTube videos in your language, you could get them captioned and translated, and you can consume videos from around the world. And various other things. We have a telephony-based system called Goog 411, which is basically local search, directory assistance over the phone, and things like that. One of the underlying themes of how we do things at Google is we try to take advantage of the fact that we live in the cloud. So we deploy things that run in servers in our data centers, and that means we have this great advantage of tons and tons of data constantly flowing in. And we do whatever we can to take advantage of that, both to find ways to improve the core technology, find ways to improve the design of applications and to be able to rapidly iterate those designs, and to find ways to look at that data to learn things about user needs and user preferences and help us think about products of the future. So Maryam is going to describe some studies that she's done looking at the logs that we collect and trying to learn things about users from those logs.
Great. Thanks, Mike. Hi, everyone. My name is Maryam Garrett, and I'll be talking about search patterns across 3 different devices and 2 different input modalities. By now, I'm sure most of you have noticed that I'm talking kind of funny and looking a little kind of funny on my right side of my face, so just so nobody thinks I'm smirking at them, I have Bell's palsy, which is a temporary paralysis of the right side of my face. So if you think I'm smirking at you, please know my intent is really to smile. So just wanted to get that out of the way so no one thinks I'm looking funny, giving them funny looks. But today I'm going to be talking, basically this talk is going to be divided into 2 parts. The first part is I'm going to be talking about speech patterns across 3 different devices. And those 3 different devices are computers, smartphones, and conventional mobile phones. And that study was joint work done in collaboration with Melanie Keller, Rajan Patel, and Ya Zhu. And Ya is actually a student here at Stanford. And that study was done in the summer of 2008. The second study I'm going to talk about is understanding how users use search differently when they're typing and speaking. And for that study, I honed in on one device, a smartphone, and tried to understand the search patterns, the differences between typing and speaking. And that study was done last summer in collaboration with Doug Refinement. Okay, so the first study, trying to understand how people search differently from computers, smartphones, and conventional mobile phones. What really motivated our study was we wanted to understand how mobile search users differ from computer-based search. I think when we did the study, the iPhone had been out about a year and a half, and was really seeming to change the face of the mobile web. So we wanted to understand quantitatively what this meant for us. And of course, anything we can do to improve the mobile search experience is always welcome. So those were the motivation behind this study. I'm going to talk a little bit about the data set, which at Google we were very fortunate to have a very large data set to work from. We called queries from 3 different search interfaces. One, just regular browser-based search. So when you're on your laptop or when you're on your desktop and you issue queries from google.com or from the little Firefox search bar, we anonymously aggregated those queries. We also looked at iPhone-based web search, so any queries that were coming from iPhones. We chose iPhone as the smartphone that we were going to look at because it was, at the time, the dominant smartphone platform. And then the third platform we looked at was just regular mobile phones, the antiquated non-smartphone variety. So they have browsers, but not as fancy, shall we say, as the iPhone or Symbian, some of the Symbian phones. So as I mentioned, this analysis was done in 2008, and we randomly selected over 10,000 users from each platform. Of course, this was all anonymous, and we have absolutely no way of tying back users to real people. So we have just about 1 million queries, some coming from, about 500,000 coming from computers, and the rest split between iPhones and conventional mobile phones. And one of the first differences that jumped out at us was that computer-based users really query a lot more than iPhone users and mobile users. And when we break that down to a little bit further to see how many queries do people do on each platform for instance, per information need, we see that computer users dive more deeply into their search session. So they issue more queries per search session than iPhones and mobile searchers. So this was, not to ruin the rest of the talk, but this was actually the biggest difference we saw between iPhone users and computer users. In all other cases, iPhone users closely mimicked search patterns of computer users, except in this case, it seems like iPhone users are still kind of in between. If the spectrum is from mobile phones to computers, they're smack dab in the middle of that spectrum. So we still have a way to go in terms of getting users more engaged on various mobile devices. But for the rest of the query statistics I'm going to talk about, I think you will probably be as surprised as we were to see how closely iPhone searches mimic computer-based searches. The first statistic we looked at was pretty simple. We just looked at query length. So on conventional mobile phones, we saw there were about 2.4 words per query and about 15.9 characters per query. And we compare that to the length of queries issued from regular computers or laptops, and we see it's much shorter than the average 2.9 words per query and 18.8 characters per query. Of course, you can say, well, this is probably due to the fact that it's much easier to enter queries on your computer because you have a full QWERTY keyboard, whereas on these old cell phones, you're still doing multitap. And of course, when we look at the iPhone, it actually falls much closer to that, to the query length issue of computers. And we think that's because, well, they do have a full QWERTY keyboard. It's just a soft keyboard. And this tells us that maybe the soft keyboard is an acceptable, or their soft keyboard is an acceptable alternative to the full QWERTY keyboard. The next metric we looked at was, yep.
Quick question on the last slide.
Mm-hmm.
So does that tell us that people on the multicast are making a decision where they say, you know, I'm only going to search if I can express what I need to say in 2.4 characters? And so the difference is really people are searching for a subset of things.
Yep.
Or is that saying, well, I'll make a shorter query because it's just too painful to make the long one, and I'll make up some of the less goodness on the display side.
Well, I think in the next slide, I'll show that I think that people are actually searching for a subset of needs on their mobile phones. It actually dealing with less good results is even worse on a mobile phone. So I don't think users are intentionally trying to save keystrokes and then trade off with a lot of browsing, because that's, probably even more painful than entering those extra 2-3 characters would have been. So, talking about what people are actually searching for, can you see that? Oh, sorry about that. But so what this graph is showing is there is this dotted line. Let's see. There's a dotted line right at 0, which is the ground truth in terms of what people are searching for on their computers. So all the categories are, set at 0 for computer-based. These green dots are the difference in categories for iPhone-based searchers. So for example, let's just take sports, which is this one up here. iPhone searchers search on average probably for 1% more sports than computer-based users do. And what was most surprising about, let's just focus on those green dots, is they actually really, really fall very close to the computer-based query category distribution. There were only 2 categories that were more than 2% different, which was pretty surprising. I think the most surprising aspect of that is local searches on the iPhone were not drastically more popular than the amount of local searches on the web. And that was very counterintuitive for us, because we thought mobile is the primary use for mobile searches is going to be local information. So we delved into that a little bit deeper, and although local searches is not much larger for web search, it actually is much larger for maps-based search. So what we did is we compared the number of searches from maps.google.com, which is the computer-based version of Google Maps, to the number of queries per user on Google Mobile Maps, which is the downloadable version of Maps on your iPhone. And we found a significantly larger number of searches. Users were doing more local searches on the iPhone version of Maps than they were on maps.google.com. So what that tells us is local content is still really important for mobile users, but just they're not getting it through the web. They're getting it through this kind of enhanced, souped-up client that can offer them a lot more than the web can. So we've talked about the green dots and how they are very similar to the distribution. iPhone category distribution seems very similar to computer-based category distribution. But then the red dots, there's actually a whole lot more difference. And the red dots indicate the distribution of regular conventional mobile phones. And down here are the categories that were, the most different. And of course, our users like to make my talks really fun and interesting by making this outlier here adult content. So so we found, I think when I first did the first large-scale analyses of mobile search, we actually found the plurality of searches coming from mobile devices were for adult content. And that was pretty shocking for me in many ways. And but we had this hypothesis that maybe it's because mobile search is still such a nascent technology. Maybe it really is just early adopters, a small demographic, looking for things they're interested in. So that was our theory 4 years ago. And to this day, unfortunately, we haven't been able to, there they're no longer early adopters. The early adopters all have iPhones now, and I mean, the adult content is much less. So my new hypothesis is that search on conventional mobile phones is so unpleasant that people only want to use it for the things they're really interested in or really need now. And for some users, that is adult content. Interestingly, also online communities is one of those topics that people really want as well. So that's like the Facebook searches, the Orkut searches. And again, I think that is actually, people want to be able to communicate from their mobile phone. This might be something, finding out what your friends are up to might be something that's worth the pain of browsing on your mobile phone. So query, in addition to looking at the diversity, the distribution of query categories, we also looked at the diversity of the individual queries. So it's just another way of essentially measuring the diversity of the query set. What this graph shows is we took the entire query set and said what percentage of those queries are unique. So the more unique queries there are, the longer the tail is of that query graph that you've probably seen. And expectedly, computer-based searches are the most diverse. There are many more unique queries on computers than on iPhones and mobile phones. But iPhones are a pretty close second in terms of diversity. 61.6% of the query set is actually, they are unique queries. And again, we see that mobile search is really lagging behind. Again, we think there might be something about the demographic or the use cases of mobile search that really restrict it to a smaller subset of either users or queries or interests.
And presumably, just basic information theory should say that diversity and query length are pretty well correlated.
Yeah, but yeah, that's true. So, although I don't know if a one-word query or 3-character one-word query length would account for all of it, all of the difference in diversity. But I agree, that definitely should be a part of it. Another metric of query diversity is the percentage of total searches accounted for by the top N most popular queries. So what this graph shows is, this is query 100. Of the top 100 queries, how many of the mobile searches were accounted for? And we draw this out all the way to 1,000. So what this graph is saying is the top 1,000 queries, top 1,000 mobile queries account for an astounding 32.8% of all traffic. Compare that to the top 1,000 computer-based searches on the computer-based searches, that's in dark red. And that's only, the top 1,000 queries only account for 10.5% of all queries. And again, we're just this graph is reinforcing the fact that iPhone searches are so much closer, iPhone search patterns are so much closer to computer-based search patterns than mobile search. I mean, it consistently looks like a spectrum of mobile search on one side, computer-based search on one side, and the iPhone search is always really, really close to the computer-based search. So I've been talking so far about query patterns in aggregate, across all users. But now I'm going to talk a little bit about, let's consider a user's query stream, in isolation. So let's not aggregate across users, but consider individual users. And I wanted to understand what the diversity of users' interests were. So we know that across all users, they tend to be more interested in a greater, there was greater diversity in query categories across all users, but what about individual users? So this graph here is a heat map. What we did was we took users who had issued at least 10 queries, and then this heat map shows the distribution of their query categories. So a vertical line indicates a single user, and how dark square is indicates how many times or the frequency that they searched in a category. So for example, it looks like this user right here was pretty heavy in the local category. Unfortunately, the resolution, you can't actually see all the different shades that well, but it's a pretty it looks pretty, all over the place. Users, individual users. Just we did some ordering so that, all these guys would appear together, but just in terms of how it looked. If you look at the distribution per iPhone user, it kind of looks pretty similar. iPhone users have a pretty diverse set of interests. And these two graphs don't look all that different. Oops, did I just show? But when we look at mobile users, well, we actually see these about, if this is all our users, that means this is about 50% of our users. 50% of our users have a strong predilection to query for one category again and again and again. So that kind of furthers the theory that maybe these mobile searchers really are looking, they have a subset of information needs which they think is worth looking for on their mobile device, and that's the only thing they're going to look for. So that we see that trend with over 50% of our mobile users. So these three heat maps that I just presented were all for users who had issued 10 or more queries, and we sampled 10 queries so that we could normalize it. What we wanted to see if we could generalize that phenomenon of are mobile users consistently interested in. Mm-hmm.
So is it true that none of the people search for any business-related queries?
No, I'm sorry. This resolution is is not as good as the one on my computer. So there are many different shades up there.
Okay,
you just can't see them.
Okay.
But I will try and post this somewhere if that's possible, and so you can actually, or it's actually in our paper, dub last year, so you can take a look. So we wanted to see if we can generalize this phenomenon, and we came up with this metric called entro%, which is basically a normalized information entropy metric, and it takes into account the number of searches a user did and the number of categories in which those searches fell. And we do see that consistently mobile searchers have a lower entro% score, which means they have a much lower diversity of interests. So the things they're querying for are consistent, I guess. Whereas we look at iPhone and computer-based users, and they're kind of all over the map. It doesn't seem like iPhone users have taken their device as a special purpose device, searching for only X or Y. It's kind of whatever information need they have, they will use the iPhone to answer it. So from all this data that we collected and analyzed, I think the three main points that we realized is, of course, I've been saying this 100 times, but search patterns of the iPhone closely mirror those of computer-based search. iPhone and computer-based searches are much more diverse than mobile-based searches. But the biggest difference between computer and iPhone-based searches is that computer-based searchers they return more often, they have more queries during the 1 month period, and also their search sessions, there seem to be, have more queries associated with them. So they're exploring their information need a little more. So what does this mean? What can we do with this information? Well, for the implications of the fact that search patterns on the iPhone closely mirror those of computer-based search are, first, we can tell that mobile search is becoming more of an extension of computer-based search. This is great because we have so much information about computer-based search that we can leverage to improve smartphone-based search. I mean, the search algorithms, Google Suggest, there's just all this information that we've been gathering for computer-based search we can really leverage for iPhone-based search and kind of ramp that up until we get the same amount of traffic from smartphones. Also, given that it's becoming a kind of extension of computer-based search, I think it really highlights the need to integrate your computer-based search experience with your phone-based search experience. So what I mean by that is if you search for something on your computer, it shouldn't be limited to your computer. You should be able to access your search history or the results from your mobile phone, because it seems like we're becoming much more fluid where we search and the information needs we have. The second finding, that users issued less query per information need on iPhones, this suggests an area for improvement. How can we make it easier for phone-based users to iterate more and explore more deeply in their information need. We should allow for easier follow-up and perhaps make it not require them to click as much to get the information they're desiring and kind of browse around, and that might help them actually get the same depth of information that they need.
Question about this?
Mm-hmm.
Is there any information about whether their needs were being more satisfied on the mobile? Because that could be another explanation why they don't drill down.
Yeah. So unfortunately, talking about clicks per query is something that I'm not supposed to be doing. So they are met, though. But I guess let's see how I can say this. Query refinement. That's a good area for investigation. Let's go with that. And we do want to make sure, I mean, they're getting the same search results, right, for the same queries. It's not like we're ranking search results differently for mobile phones. We actually used to do that, but we're not doing that anymore. So I don't think it's a difference in the quality of our search results. The quality of our search results are the same, but maybe they have a little less patience to click. Maybe they want it to be in the top 2 results for their smartphone, but they need it, you know, if it was in the top 10 on their computer, they'd be satisfied. So maybe we need to recalibrate something there with our search results and how they're presented. I actually think how they're presented is key, because users are going to be willing to click on a computer but may not be willing to click on a phone, because you incur such unless you're on Wi-Fi, you incur such a latency in loading and rendering the page. So, and the last finding was about the diversity of information needs. And this primarily was an opportunity for, in mobile search, in the conventional mobile search, we have a pretty good understanding. If they've searched, 2 or 3 times, we're pretty certain we know what they're going to search for that 4th time. So we can actually do a lot to make their search experience better. Maybe prefetch some queries, prefetch some results, maybe target the Google homepage to their interest. If they're an avid sports querier, maybe we should suggest some of those, sports one box on their iGoogle page, or really kind of tailor their mobile search experience, since it already seems that they're doing that themselves. Yes?
So is this set of content accessible to iPhones versus mobile phones actually the same? Because it could be that people on mobile phones prefer queries of a certain type because that content, the content base is different. That's
so you're saying, like, perhaps people are doing less movie searches or YouTube searches, for example. Yeah, that might be the case. I mean, the search results themselves aren't limited. So theoretically, no, they're not limited, but users probably have some prior, thoughts about, I shouldn't search. It's pointless to search for this on my phone because I won't be able to consume the data. So that again goes to my point that I think we should be changing the format of some queries, some search results, so that they can be consumed on the low-end mobile phones. Just to make it easier for them to consume that information, whether it be so that they don't have to click, so that they don't have to worry about not having a Flash plugin, So, good question. Yes?
Is it your expectation that as more and more devices are smartphones, that the differences are going to be diminishing?
Yep, I do think that. And of course, this is just me. And other people have different thoughts, but I really do think we will see not necessarily a convergence, but I mean, the stuff you're searching for on your smartphone, if you had your computer, you would have searched for it. That nobody's going to save a search to go back to their computer and do it. Whenever the information need arises, they will do it from whatever device is most accessible,
Do you have enough longitudinal data yet? You mentioned earlier the hypothesis about early adopters on the cheap phones. Mm-hmm. But you presumably are still somewhat in the early adopter phase of iPhones.
It seemed we have updated the study, and there hasn't been huge shifts between, I guess when I did the study, the iPhone was a year and a half old, and now it's probably 3 years old. So it doesn't seem like the iPhone study was heavily influenced by the early adopter trend, but indeed there might be some changes still to come when, my grandmother gets an iPhone. So I think that is still, what? Oh, Nexus 1, sorry, that's right. So I think there are changes yet to come, but it does seem somewhat stable right now. When I did the study, I don't think it was only the early adopters. And the iPhone in particular, I think, was a platform that was widely adopted. The marketing was not at all targeted towards the computer scientists. It was really targeted towards a broad audience. So I think we got away from the early adopter phenomenon there.
So I wanted to push back on a little bit of, it's not like people save a search for later. On email, I often will do triage on a mobile device where everything that's reasonably easy to deal with, you deal with, and the stuff that's really complicated, for some definition, complicated, you save for later. And
but is that because of the device or the situation you're in? Is it because you're walking and you're trying to do 7 things so you won't do it, or is it because of the?
So that was my question. Is
Okay.
It seems like there are at least 3 big things to look for. One is input and output limitations to the device. The second one is network latency. And the third one is brevity of the interaction. And have you done the regression where you look at, okay, this much of the difference in search is explainable by network latency, because sometimes you're on a slow network even on your computer. This much we're guessing is because of the device.
Yep.
And this third one has something to do with the brevity of your situation.
We've tried to do some analysis about how people search differently if they're on Wi-Fi on their phone and just the GPRS connection. But unfortunately, it's really hard to know from our perspective if the user's on Wi-Fi or not, because IP addresses are not fixed for some of the carriers. So, but I agree, that would be very fascinating to break it down that way. But I guess looking forward, I do kind of expect all of those aspects, except the brevity thing, to improve. We will get better input-output on your device, and we will be getting, faster connections just across the board that will become, I think, more standard. So I think that going forward, those 2 factors will be mitigated by the fact that I just think that phones will always have at least in the cities in the U.S., will have a fast connection, for example. But even about the brevity of interaction, I find myself sitting on the couch, my laptop's just too far to get, so I'll just use my phone now. So I think we're getting there. Clear, certainly not yet, but now I'll talk about, when the aspects you raised, the input, output, or at least the input. So in the second part, the second study we did, this was in collaboration with my colleague Doug Refinement, we took one platform, the smartphone, and we wanted to understand how queries or search patterns were different if the user was inputting their text versus typing and versus speaking. The motivation here was we had just launched voice search, and we wanted to understand how and if it was changing the face of mobile search. Or I suppose we had launched voice search a year prior to the study, so we had gotten enough kind of magnitude that we could do this study. And of course, we always want to improve the search experience as well. So in terms of the data set, we looked at we looked at a random sample of the voice search queries coming from a downloadable application called Google Mobile Application. And the reason we chose this platform was because it offers a nearly identical experience when you're searching and typing, of course, or nearly search experience despite whatever input modality you choose. I mean, you either type the query or you hold down a button and speak the query, but that's where the differences in the interface end. You get the same search results, you have to open the same application, so it seemed like we were controlling for a lot by restricting this to this one platform. We did all our analysis on the Google mobile applications that were installed on BlackBerries. We chose the BlackBerry for several reasons, one of which was because it was a significant source of our utterances or our spoken queries. And from this data set, we further restricted our data set to those users who had issued at least one typed and one spoken query. And we did this to make sure that all of our users were aware of both options, so that they knew about the option to speak, basically. And that was 21% of all users who had issued a query in GMA had spoken and typed at least one query. So we had over 1.3 million queries during August of 2009. And again, these are randomly sampled users, and we have no idea who they are, and no way to correlate any of these back to any other queries. But so the raw probability of speaking a query, that is just the chance that when a user opens the Google mobile app that they will choose to speak a query, is 0.35, which is actually not bad. And so I'm going to be talking about what factors are correlated with speaking queries. And so essentially what we were looking for were factors where the prior probability is significantly greater than 0.352. There were two main categories of factors we looked at. First was the difficulty of typing a query. So does the difficulty of typing a query, push a user towards speaking a query? The first thing we looked at was keyboard type. So does keyboard type influence the probability a user will speak a query? Now, BlackBerrys have three different types of keyboards: the full keyboard, the compressed keyboard, which is the one where two letters are on one key, and then a soft keyboard. Unfortunately, there was only one phone with a soft keyboard, and Google mobile app was not available for that phone, so we were restricted to analyzing full keyboards and the compressed keyboards. But we do see, indeed, that users are more likely to speak a query if the keyboard is suboptimal. So the probability of speaking a query on a compressed keyboard was 0.4, whereas if you had the full hard QWERTY keyboard, the probability was only 0.35. Another metric of difficulty of entering a query is query length. So obviously, longer queries are harder to enter because you have to do more key presses. And I should mention that in analyzing voice search, it's actually a little bit tricky because we don't know the ground truth. We don't know for sure what the user meant to query for because it's dependent on our recognition technology. So the user might have said Palo Alto, but we might have recognized it as Oreo cookie, and that is just, we don't know that they really intended to say Palo Alto. So all the statistics I'm going to present today, I'm actually going to present two. One is, the metric for all the spoken queries we've gotten, and that's the green dot usually. And the second statistic is just the queries whose recognizer confidence score was 0.8. And recognizer confidence is an internal metric we've come up with to kind of guesstimate the chance we actually got the utterance right. So the chance we actually correctly identified what the user meant to say. So I think keep in mind when I present these statistics, the ground truth is probably somewhere in between the green dot and the red bar.
Maryam, do you ever have folks listen to what users say as a way of improving the recognizer or checking these kinds of numbers?
Yeah, we sometimes, but it's just not scalable. So, but it's great for small-scale user studies to be able to do that kind of thing and identify areas of improvement just in a smaller sample. So when we looked at query length, we found something surprising. I mean, my gut instinct would be that users would be much more likely to speak longer queries because, well, they're a lot harder to type. But we didn't really see that. Instead, what we saw was basically, sure, it increases for a couple words. Up to 5 words, you see, we're pretty much monotonically increasing the probability that a user will speak a query. But then something happens at 6, and we kind of have this inflection point down. We don't know exactly why this is happening, but there's a lot of theories. I mean, one, is it us or is it them? We don't know. Is it us? Is it our recognition technology that's bad and users think that if they're going to speak something long, we'll probably get it wrong? Or is it them? I think George Miller has this theory that humans can process information in units of 7 plus or minus 2, and maybe users only have this articulatory buffer of 6 words that they can say before they'll forget it all. I don't know. I don't know what the answer is, but I think this really opened up an area for a lot of interesting future work to be done on the smaller scale. So this is the kind of stuff that needs to be followed up with, why didn't you say this query versus type this query, which we can't do in logs-based analysis, but it certainly would be fascinating to delve into for smaller scale studies. Yes?
Back on that last slide, it almost seems that if users may be assuming that you're more likely to be inaccurate on a longer query, but based on the difference between the all queries and the confidence, you're probably more likely to get it right the longer it is, right?
Right, yeah, but so maybe it's not really us, but it's the user's perception of us. But again, like we also, this kind of study is a little bit convoluted because our recognizer may be biased towards shortening queries. So if they said, hi, my name is Maryam, and I'm wondering if this works, maybe we just recognize that as Oreo cookie, you know, and then we have no way of knowing they really said a long query. So again, this is a little bit, doing voice search analysis on a large scale is a little tricky because you just always have to keep in the back of your mind the fact that you don't know ground truth. But so hence the need to follow this up with smaller scale studies. But I do think that this data is incredibly valuable for kind of opening up doors for future exploration and trying to pinpoint areas that we should be exploring more.
Are you really doing continuous speech or expect people to essentially break up the words?
So right now we are, if I understand your question correctly.
Continuous speech recognition, so basically you run the words together like you just did.
Exactly.
Most recognizers have a problem.
So right now we require the user to say their entire query, then we recognize it and tell them what we think they said. But there is an argument that we should be kind of recognizing as they go, maybe saying, you know, when they say hello, we immediately transcribe hello and show them that we got it. Maybe that would instill more confidence. Maybe that would, you know, require less of an articulatory buffer in their head if we kind of, it's, you know, we pop it out onto the display. So yeah, that might change the way people interact with our input as well, voice input. And again, the third metric of query difficulty, input difficulty, is query popularity. So if there are really common queries, you know, whatever the most common query is, let's just say that's Oreo cookie, that might be perceived as users as really easy to type because it's probably in their Google Suggest. It will probably be the first query that pops up is, you know, when they type O, they'll probably see Google suggests Oreo cookie, and that will be it. So maybe those queries are easy, perceived as easy to enter. But on the other hand, maybe users have a preconceived notion that really common queries are probably easier for us to recognize. Turns out we couldn't find anything interesting in query popularity. It doesn't seem that users have a preconceived notion about how easy or hard it would be to type a query based on query popularity. And it was a little bit of a stretch. I don't know how many of you think about how popular a query is before you type it in. So the second subset we looked into was query topic. We looked into query classification, two ways of classifying a query. One, the actual query, we classified the query itself into one of 30 categories. And then secondly, we also tried to categorize the search results that were returned from the query. So the blue line there is the raw probability a user will speak a query. So anything to the right, the green dots to the right, means a user is more likely to speak that query in that category. And we found that users are much more likely to speak food and drink, local, shopping, and travel queries. I'm going to hold off on the implications of this until I talk about the categories we found for the search results. And sorry about that, but what we found was queries that returned a one box or, you know, a quick result kind of search results. That is, you know, when you type in something with a local query, you get the maps one box with the information already presented to you. You don't have to click through. There's also the images one box and the news one box there that kind of gives you extra information without requiring the user to click through. We found that those were all very popular for spoken queries. So combining this evidence with the search results, the query categories that were queried for often, we took it to mean that users really wanted start-to-end hands-free experience. So they not only wanted to communicate their query in a hands-free experience, but they wanted to then consume the search results in a hands-free experience as well. So they didn't want to have to click and, kind of, I guess, hands-free and less eye-intensive. They didn't want to read up and down a whole lot. They just wanted a really concise way of representing their voice search queries.
What's the vertical axis there on that graph?
The blue line? Oh gosh, sorry about. So is the probability of a spoken query given the type of search result returned. So if there was a maps one box, the probability of speaking a query was somewhere around 0.5. So that's the green dot. And then did you ask about the x-axis or the y-axis? Oh, the y-axis are the different kinds of quick results we gave back. So the maps, so the bottom is maps, the second highest is images, news, video, and spelling. And actually what's interesting is you'll see spelling, the top one, is you're much less likely to speak a result that results in a spelling suggestion. Well, that's because if you don't know how to spell something, you speak it and we will spell it correctly for you. So that was a kind of nice side effect of a benefit of spoken search. You don't have to know how to spell it. And as a result, we're seeing less spelling errors or did you means. I think I might run out of time, but the next thing we looked into was user patterns. So again, we've been looking at before this just aggregate query patterns, and we wanted to understand a little bit more about user patterns, what a single user does within their interaction with GMA, because you can switch between typing and speaking at any point, and we want to understand when this switch happens. When will they go from typing to speaking and speaking to typing within a single search session? And so, well, we created this, nice state diagram, and there are 4 different states: the beginning of a session, the end of a session, a spoken query, or typed query. And all I want to say about this slide is that almost 40% of all GMA search sessions had a spoken query, which really, this was great because it really said to us that voice search is not a fringe movement. I mean, a lot of people are actually engaging with voice search and want to see it. So this is the state machine of all the users' sessions. And the most striking thing here was that users who started in a single input modality really wanted to stay in that input modality. So we see if they started with a spoken query, the chances they would continue for the rest of their sessions speaking was pretty high, same with typing. But of course, the transition from spoken to typed is higher than from typed to spoken. So we wanted to understand why are users leaving spoken queries at a higher rate than they are leaving typed queries to come and speak. And this is going to be an eye chart. But basically what this is showing us is that where we were losing users was when they tried to edit their spoken queries. So let's say they did say, a 4-word query, and then we got one of the words wrong. They would go and type that rather than re-speaking it. And again, that really pointed out an area that we can improve on, making it easier for users to just edit part of their query. Because right now, voice search is all or nothing. You have to say the entire query, and if we don't get it right, you have to say the entire query again. So it would definitely be useful to allow our users to edit their voice search queries so that they don't have to switch to typed, given that it doesn't seem they want to search to typed.
Do you have any intuition for how you would design that so that it would allow for better interaction?
Yeah, I mean, well, so at least on Android, which we can control that a little more than on other platforms. I mean, we're doing some really basic things to make it easier for users to edit. We're letting them select just one part of their query and then say re-speak, and then, that just wasn't possible before. But it's unclear if that would have been a priority if we hadn't done this kind of analysis, because it wasn't at the forefront of anyone's, list of things to do. So lots of basic things like that. And then, but this has many more implications when we move to, so it's important for voice search to allow users to edit queries. But, queries are mostly like 3 words long. not that big of a deal to re-speak the whole thing. But when we get to talk anywhere, if you can talk to your Gmail and dictate a Gmail, and then we get something wrong and the user feels they have to re-speak their entire email, well, that's just not going to work. So I think we're working towards making it easier across the board to edit any voice input. And we're still experimenting with different ideas. This is actually a pretty new result. So hopefully in the next version of Android, you'll see some new improvements that make it easier and more intuitive to edit your queries or input. So I guess I'll just kind of rush through these key findings because I'm running out of time here. But again, we found that counterintuitively, users aren't speaking long queries. That voice input is seems to be more essential for phones with compromised keyboards than the full keyboards. And lastly, that users really want a search experience that's hands-free from start to end. So far, we've been focusing on providing them a hands-free experience to start their search session, but then we kind of drop off there, and I think it's important to really extend that hands-free experience. The implications of each one of these are of course, they just really lend themselves to further investigation. We really need to understand more why users aren't speaking their long queries. We had a discussion about that earlier, but is it us or is it them is something we'd like to understand. Because if it is them, let's say people just don't want to speak long queries, or they don't want to say something that takes a long time to their phone, well, maybe that has implications for our Speak Anywhere functionality. But hopefully it's us, because that's something we can fix. Again, voice input, more essential for phones with suboptimal keyboards. I think the cool thing about this was that we see more and more phones coming out with suboptimal keyboards. So it actually is an indication that I think voice search is going to take off a lot more, because we're seeing a lot more phones come smaller and with all the soft keyboards, which might not be ideal for inputting text. So I do think this has good implications for voice search. And again, we just talked about providing more of a start-to-end hands-free experience for voice, especially for queries that start with voice input. We need to really ensure that we are allowing users to complete their search experience from editing their query to consuming the search results in a hands-free manner. So that's it. I guess I wanted to close with asking you all, I guess everybody, all the apps we kind of develop now have some kind of cloud component. That is, they all connect to a server. So I'd like to encourage you all to think about how you can use the logging data to really understand your users better and iterate on your design, because I think it's a really valuable tool to be used in complementary to the traditional lab-based studies.
To do this kind of analysis? Like you're Google, so you have literally millions.
Yeah.
You can analyze.
So I suppose that it all depends how often your users are using your application, and so there's no magic number. I can't give you a magic number, but you can always test for statistical significance to make sure that your results are, at least statistically significant. But sorry, I can't give you a magic number. Yes?
I guess I can give you one magic number, given from what you said, but I have to first preface it by my question. Given your comments about privacy, you seem to say that speaker identification is now possible.
We can't correlate.
You cannot figure out who the speaker was, given what you said.
Right.
And there's a whole field of speaker identification.
Okay.
And you're basically saying now that's not possible.
Oh.
Or you're not just doing it, but that's still.
So I said
you have to speak to them.
Right. So we could, if the users wanted, I'm sure they could log in and we could say, yes, your queries are you, and that has implications. Maybe we would.
No, I'm talking about not logging without knowing, basically.
Your logs record the audio, or they're just the
temporarily for a very short period of time, and then we get rid of them. So we do have some audio data from which to learn, but we don't store them forever.
Well, let me jump to the end and answer.
Okay.
It takes about 30,000 characters. If in characters, for the statistics converge to the speaker identification or authorship identification, if you wish.
Okay. So,
It's not impossible. It takes a little extra, but it's not impossible.
right. I guess.
That's without logging in.
Yeah, so we are not violating any user's privacy by trying to identify them.
I happen to be on the other side, so
Okay,
you should be aware of what's possible, what's not possible.
right. Great. Yes?
I had a question going back to the going from voice search back to type search. In the case of refinements, do you have an idea of how far off base the corrections are? You know, if the user said Eiffel Tower and ended up Oreo cookie,
Yeah.
and how many of those instances are just something that your voice translation engine can't handle? And in that case, do you have an idea of, like it's not something that voice translation engine can come up with? In that case, do you have an idea of how you would enable a voice correction of that?
So in terms of, have I done for example, an edit distance calculation between the refinements and the actual queries? I haven't, but I don't, has Doug or anyone else, do you know?
I understand the question. So,
Okay, it's kind of two questions. So first of all, do you have an idea of how many of the refinements are something that your translation engine would actually generate?
So are you asking
So,
what
for
misses
example,
in our database?
if they edit it and they add a word, and the word might be outside of our vocabulary or
Right,
something?
right.
Yeah, that's certainly something that we could measure easily. I don't think we looked at that. But, well, we
I don't
look
remember
at
the last numbers.
vocabulary rates, and they're very, very low. I mean, we use
Okay.
vocabulary sizes of 1,000,000 words or something, and that's
And-
very, very big coverage. So,
The second part of the question was, if it is outside of your vocabulary, how would you enable the user to refine that using voice rather than typing? Just have them spell it out verbally, or?
yeah, if it's outside of a vocabulary, we're not going to recognize the
Yeah.
word. Somehow it has to be in there, or our recognizer won't hypothesize it. It's possible to enable spelling. Spelling is difficult. It's a small vocabulary, so it should be easy. In English, there's the E set, 9 different letters, B, D, B, G, and so on. And most of the energy is, fairly similar. So it's not clear. Maybe that would be a way to allow people to recover in that case. But that also gets a good tease. By the time you're having to do that, maybe you might as well type at that point.
So your recognition set for written is basically anything on the web. So what do you do for spoken? A new proper noun enters vocabulary. Do you add it to your voice?
Yeah, so there are various things. From time to time, we refresh the language model, which means, we train language models, in other words, statistical models of word strings on real queries, not just spoken queries, but queries that people have typed. And this may be trained on hundreds of billions of queries. And we find that if we refresh that from time to time, get statistics over the last few months, we get a very dramatic improvement, even though it's a little bit of extra data. And part of what that does is it adds some new words to the vocabulary, and part of it is it adds some new statistics. Some dramatic event in the world happens, and there's suddenly a new name in the news, and lots of people may query about that. Being Google, we have lots of queries, textual queries that will cover those things. So by refreshing the language model from time to time, you can learn that.
Doesn't that suggest you should do it more often? News travels fast, so you should, at least for those exceptions, you should be updating much more quickly. Otherwise, people get disenchanted with your voice input.
That's the ideal case, to have a constantly updating language model.
Well, there's something to be said about it, because you can actually learn quite a bit more doing it continuously. Analogous to continuous speech versus non-continuous speech.
Right.
There's something to be learned there. Among other things, you mentioned the DP, whatever. Some things, if you have the wrong techniques, you will never be able to tell the difference. That's the first thing you should be able to learn. And maybe your techniques on it, if you do free transform, that technique you're probably using. You're losing all the closest stuff.
Right. Yeah.
So,
Everything
well,
dynamic you do not see.
I agree with you that, refreshing language models more often can be useful. On the other hand, we do track things like added vocabulary rates, and when we do transcription and stuff, and it's very small. So that doesn't indicate that that's a huge factor.
Well, in average, the point is there's a point in time, and that's a newsworthy impulse is the point.
Yeah, I agree with you.
Great. Oh, yes.
In the study on the voice versus text, you described how you were not able to use a soft keyboard as a counterexample there.
Right.
I've seen data comparing iPhone and BlackBerries, which indicate the numbers actually invert from what you're saying. The number of voice input onto iPhone significantly outweighs when the comparative interface there on the BlackBerry. So my question to you is, since this study, have you been able to have an opportunity of doing something similar on iPhones or Android devices, et cetera, that might give some insight as to how this might look like with, say, an iPhone or a device that does not have a keyboard or soft keyboard?
So let me just go back to the first half of your point. I think that it would be in line with our results to think that more people would speak queries to iPhones than they would to BlackBerries with full keyboards, because I think as the quality of your keyboard degrades, you get more and more people speaking queries. So I think that is that what you said the finding was?
Yeah, no, the data I've seen indicates that it's very, very clearly on the iPhone side, people are speaking into the interface.
Exactly.
As an equivalent text interface.
Yeah, so I would agree with that, and I think that the next really cool study to do would be kind of a holy grail of common platform using different Android devices. We now have the Droid, the Nexus One, and what I'm saying is we actually have one phone, one platform with different form factors that all run the same kinds of applications. And I think that study is going to be really fascinating to be able to control for all different kinds of form factors, screen size, while maintaining the same exact platform. Because you also run into a little bit of confounding factors when you try and compare a BlackBerry to an iPhone, because a BlackBerry is a little more outdated. So I agree with you. It's a really, I think, adding more layers to that analysis will be really interesting, and I hope to do so through analyzing all the different Android possibilities that are out there.
Okay, well, thank you very much.
Great, thank you.
For more, please visit us at stanford.edu.